In this video, I will be demonstrating various sorting algorithms, and the first one is insertion sort. So the goal of a sort is to have an increase from left to right, and that would be considered a sorted, in this example, array of integers. So in insertion sort, we go to the first, well, in an insertion sort, we look at the second one, not the first one, because there's no value to the left of it. Because an insertion sort compares always to the left of it. So then we'll go to the second place, which is a 4, and which will be and then our first comparison would be, is 4 greater than or less than 2? And it's not, so it'll stay there. Then we'll go to the next one, is 7 less than or greater than 4? And it's not, so it'll stay there. It'll go to the fourth one, is 3 less than or greater than 7? And it is, so these two items will swap. And then the next comparison would be, is 3 greater than or less than 4? And it is, so they swap. And then our next comparison would be, is 8 less than or greater than 7? And it's not, so it stays there. Our next item would be this 1 here, and then we compare it first to the left, which would be less than, so it swaps. Compares it to the left again, it swaps, and to the left, and to the left, and to the left, until obviously the 1 lands into the most bottom area. So then you can see that the next item that we need to compare is 5. Compared to 8 is less than, so they swap. Compared to 7, and then it stops because when it compares it to the leftmost item, which is 4, it is greater than, so it doesn't do anything. And then we can see similarly the last item is 6. It's less than 8, it swaps, and is less than 7, it swaps, but is not less than 5, so it stays there. And now we finally have increasing from 1 to 8, from left to right, and this is a sorted array of integers. The next sorting algorithm is the selection sort. And in a selection sort, you iterate through the whole list of values and grab the lowest value and put it to the leftmost place in the first place. So we'll start with the first one. In the first iteration, we'll grab the smallest integer of the whole array. So we'll have to set a minimum value, which is the first one. So 3 is the minimum value so far. Compared to 1, 3 is greater than 1, so now 1 becomes our minimum value. 1 is less than 4, less than 7, less than 5, less than 6, less than 2, and less than 8. So that means, so after we know that 1 is the smallest value in our list, so that value and the first item that we're comparing to is swapped. We can move on to 3 and on because we know that 1 is already sorted. So 3 becomes our minimum value. 3 is less than 4, 3 is less than 7, 3 is less than 5, 3 is less than 6, but it's not less than 2. So 2 becomes our least, or the 2 becomes the lowest value, and 2 is less than 8. So what happens now is it's 2 is swapped with the leftmost integer in the sorting section of our array. So the 2 comes here and the 3 goes where the 2 was. So the 1 and the 2 are considered already sorted, so we can move on to the 4. 4 is less than 4 is the first value. 4 is set to the minimum value, so 4 is less than 7, less than 5, less than 6, but it's not less than 3. So we can swap these. 1, 2, 3 is already sorted. We move on to 7. 7 is greater than 5. 5 is our minimum value. So 5 is less than 6, but 5 is not less than 4. 4 becomes our minimum value. Compared to 8, it's less than. So we take the minimum value, which is 4, and swap it with the first item in the sorting section of our array. 1, 2, 3, 4 is already sorted, so we only look at 4, 5, 7, and 8. Are comparing our first integer in the comparison area is 5, set to the minimum value. 5 is less than 6, less than 7, less than 8, it stays there. 6 is less than 7 than 8, so it stays there. 7, so 1, 2, 3, 4, 5, 6 is considered sorted. We only look at 7 and 8, and 7, minimum value, is less than 8, so it stays there. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, and this array of integers is sorted. The next sorting algorithm is the merge sort. And for simplicity's sake, I will be using 4 items, 1 through 4. And okay, so first in a merge sort, we will split the items, or the whole array in half. So we have this, a 3 and a 4, and a 2 and a 4. And then within these two sections, we will order them within themselves. So 1 is less than 3, so these switch, and this is already sorted, 2 and a 4. So now, within these two subcategories, they're already sorted, so we can compare the first item of each section to each other and move them so they can be sorted. So 1 would be compared to 2. 1 is less than 2, so it goes first. Next compared, 3 is compared to 4. 3 is less than, so 3 goes first, followed by the 4. This can be applied to a much larger array of integers or what have you, and it would split it down into multiple selections and keep splitting them down until they all merge together at one point, as I've shown here. Okay, so now we'll be talking about searches, 2 kinds, a linear and binary. In a linear search, well, in a search we're looking for a certain value amongst a, in this case, an array of integers. So let's say we're searching for the integer 1. So we'll iterate through the array, and if it's been found, then stop and we found it. So if it's 1, 1 is not 2, 1 is not 7, 1 is not 4, but 1 is 1, so we have found the value and we stop. Let's say the value we're searching for is 5. So we'll iterate through until we found it, 2, 7, 4, 1, 8, 5, and we found it. So that is quite simply the linear search. In a binary search, you need an array that has already been sorted. So in this case, we have a sorted array, and in this search, let's say we're looking for 6. So what we'll do first is we'll take the middle term, which we can find by saying the total number divided by 2, and we can easily get the middle term as 4. The middle term 3 and 3, so we can look at 4, and if it's the number we're looking for, then great, we found it. But if it's not, we'll compare it to the middle term with 4. So 6 is greater than 4. So we can discard the middle integer and everything to the left of it because it's greater than. So now we're only looking at these 3 integers. So we take the middle term, which is 6. And if it is 6, which we are looking for, then we found it and our search is done. Okay, I hope I've accurately and adequately described the sorting and searching algorithms. And thanks for watching. Peace.